In this video, we're going to talk about data aggregation in pandas. So let me start by first saying that data aggregation is what's called an overloaded term, meaning that we use one word to refer to multiple ideas. Aggregation not only refers to data summarization, as I described before, but also to the combining of different data sets. So the reason I bring this up is because some data aggregations are very simple, like calculating a mean. Here, we're simply summarizing some data set with a smaller set of numbers. But aggregation can also refer to a more complex workflow that follows a pattern called split, apply, combine. The Pandas documentation has an entire user guide page dedicated to this pattern of analysis, and it is exemplified or managed by the groupby operation. So there is a groupby method in Pandas that's very similar to the SQL groupby, if you're used to that. And we'll be talking about that in some detail during this video. But the idea essentially is that we first split the data into some groups, then we apply some function to each group. This is usually an aggregating function, a summarizing function. So we represent each group by some statistic or some representative subset of the group. And then we finally combine the results of our aggregation, our summarization, into a final data structure. And people sometimes use aggregation to refer to this act of combining results, and sometimes they use it to refer to this act of applying a summarization function to one or more groups. And as the Pandas user guide points out, in the apply step, we could apply any function. It could be an aggregation, a transformation, or filtration, which means that people may call an operation an aggregation because it uses a groupby, even if no aggregation is involved. Usually, when I say aggregation, I am referring to this operation, where computing a summary statistic or some kind of summary for a group is involved in some way. I should also highlight that this user guide is a great resource for learning more about what we will talk about in this lecture. So, why might we want to do something like this? Why would we want to split up the data, aggregate some quantity according to the groups, and then recombine it? Well, described in those abstract terms, it might sound a little bit useless. But let's consider a very simple, concrete example. We have businesses that are distributed across different cities in our data frame. So each business resides in some city, and each business also has a star rating. And we might be interested in what the average star rating is for businesses in different cities. So the average star rating of businesses by city. In that case, we should split up the data according to what city each business is in, and then calculate the mean star rating for each on a group by group basis, on a city by city basis, and then finally recombine our results from each city. We can accomplish that by taking our data frame and using the groupby method to group it by city. Then we can select the stars series and compute a mean. This gives us the average star rating for each city. Notice a few things about what just happened. First of all, our result, stars by city, only has 167 rows, while the Yelp data frame has 38,000 rows. The reason is the number of cities in the data frame is 167. We got one output for each city. There were 167 unique cities in the original data frame, so we got 167 outputs. Secondly, the output was indexed by city. Whenever we perform an aggregation with a group by, the values in the columns that we group by end up being the index of the output. This is because we get a single answer for each group. The groups are constructed from the values in the fields that we group by. If you've been working through the PW mini project, you've had to implement your own group by scheme to solve questions 2, 3, and 4 in the PW mini project. So hopefully you have a pretty good idea at this point of how what's sort of going on behind the scenes in pandas with the group by method. In fact, let's investigate a little bit how group by works. The group by method returns what's called a group by object. If we're grouping a series, we'll get a series group by object. And if we're grouping a data frame, we get a data frame group by object. We can take a data frame group by object and select a particular series out of it, getting a series group by object. So we can first select a series and then group by another series, or we can group an entire data frame by some series or set of series, and then select out a series from the data frame group by object. Notice there's no visual representation of what this data frame group by object is. It's a little bit mysterious. And that's because generally we don't work with data frame group by objects. We don't usually store them as variables. Instead, we're almost always performing a group by on the way to performing some aggregation. So we'll pretty much never stop at this group by object. We'll instead chain on some kind of aggregating method like we did before with computing a mean. What's the internal structure of this group by object? How does it operate? The group by object is essentially a dictionary. So the group by object has a groups attribute, which we can see is a dictionary. If we inspect the items of that dictionary, we find that the keys correspond with the values in the field, the unique values of the field that we grouped by. In this case, the city names. The values of the dictionary are all the indices belonging to a particular group. So rows 1718, 1740, 13572, 17787, 2361, etc., all of those rows have businesses in Ahwatukee. Arcadia only one business was in Arcadia, row 20,625. The purpose of the groupby object is to excuse me, use these groups to coordinate the application of aggregating functions. If we inspect the attributes and methods of a groupby object, we can see that apply and aggregate are among the methods available to us with a groupby object, as well as things like max, mean, median, sum, standard deviation, and many other statistical aggregations that we might expect to use to summarize the data. So we can take a groupby object and apply aggregations to each group. We can also retrieve particular groups from the groupby object. However, this has very limited use, since we could just as easily say Yelp DF, where the city is Anthem. This is much more efficient, since we don't have to go through the process of constructing all of the groups in the all of the city groups just to retrieve a single group. So we'll almost never do this. Generally, as I said before, we perform a groupby on the way to performing some kind of aggregation. We almost never interact with groupby objects directly. Here, in the above example, we applied just a single aggregating function to our groups. But many times we'll want to calculate multiple statistics associated with each group. For that, we can use the agg method. Agg allows us to pass in a dictionary specifying what fields we want to aggregate and how. In this example, we're aggregating the stars column, we're grouping the data frame by city, and for each city, we're going to calculate the mean and standard deviation of the star ratings, the total number of reviews, and the number of businesses. Here, since each of these operations, mean, standard deviation, sum, and count, are built into pandas, we can simply give the names of the functions that we want to invoke. As output, we get a hierarchical set of column names where we have the names of the original columns, and then under that we have the names of the aggregating function applied. So we can see the hierarchy of the aggregations we specified translates into a hierarchy of labels in the output. So we ended up with our mean and standard deviation of the stars for each city, along with these aggregations for the other fields that we selected. If we wanted to access particular series from this output, we could first select the name of this upper level of column names, and then the lower level of column names that we want. We can also use ag or apply to aggregate groups using custom function definitions, as we did previously to perform a custom data transformation. So just like we can define our own functions to perform transformations, we can define our own functions to perform aggregations. So for example, say we wanted to get the let's see. Let's say we wanted to get the business with the alphabetically first name in each city. I don't know why we would necessarily want to do this, but we could take our data frame, group by city, since we want to get the alphabetically first business for each city. Obviously, if we're getting the alphabetically first name, we'll need to select the name series. And for each string in the group, we want, I guess this would just be a min, wouldn't it? Indeed, yeah. Okay, so not quite gonna work there. I'll have to think of something else. A lot of aggregations boil down to like mins, max, means, sums, that sort of thing. It's hard to think of something else to do off the top of my head. Okay, I have an idea. So say that we wanted the a list of the categories, the set of categories of all businesses in a city. And maybe we wanted actually the number of different categories that the businesses in a city cover. And this would give us an idea of the diversity of services available in that city. So for each city, we want one number expressing the number of unique categories across all the businesses. So this is going to be an aggregation on the categories column by city. And in this case, when we define our aggregating function, we'll say count categories. This should be n unique. Let's check something real fast here. No. Okay, it's not n unique. We see here for Arcadia, there is a business with a variety of categories. It appears to be some kind of school or something. Infant swimming resource. So a school, I guess, where they teach babies to swim. And this has many categories. But in our result, when we use n unique, it's getting counted as 1 because it's one unique list. So n unique here is going to compare the lists, but we want to compare the unique categories across all businesses. So we'll define a function, count categories, and this function, unlike previously with our apply, this is going to get a group as an argument. So we're going to eventually apply count categories. But that count categories function is going to receive a group as input. What do I mean by group? I mean a data frame consisting of all the rows belonging to a particular city group. So for example, the Arcadia group is a data frame containing this single row. The Ahwatukee group is a data frame containing these 8 rows. What do we want to do with this group? Well, we want to essentially return the length of a set of let's see here. Categories is going to be a set, and for each row in the group, we're going to update that set with the categories list in that row. Finally, we'll return the length of that set, because that'll give us the number of unique categories. Okay, that didn't quite work. Dictionary update sequence element. Aha. There we go. So now we see Arcadia has a count of 5 for the 5 categories in that business's categories list. One, two, three, four, 5. So we can define custom functions that we can use in our aggregations as well. And here I used apply because I was only applying a single aggregation. We usually only use the ag method when we're performing multiple aggregations, either on one or more series. Before we conclude our discussion of aggregations, I want to mention a few tips for thinking about aggregations and transformations. First of all, if ever you find yourself writing for something in pandas object, whether this is a series or a data frame, there is probably a better way to do whatever you're trying to do by instead taking that pandas object and using an apply method. So almost never will we explicitly iterate over pandas objects. Almost always we will instead use apply or aggregate. Secondly, apply and aggregate take functions as arguments. and they pass the contents of the pandas object into that function as arguments to the function you are applying. We always need to think when we're going to apply some kind of function, like we did here, what the argument of that function should be. If we're in the process of performing an aggregation with a groupby, whatever function we're applying is going to receive a group data frame or series as a argument. Here, it's going to be a series because we picked out a single series. But if we hadn't picked out that series, we'd get a data frame here. In contrast, when we were doing transformations, and we defined the getDelivery function, the apply method took the elements of this series and passed those one by one as individual arguments to the getDelivery attribute function. So in one case, we got an entire group, an entire pandas object as an argument. And in the other case, we got the elements of that pandas object as arguments. Unfortunately, this is just something that we need to get used to and practice, but we should always be in the habit of thinking, what is apply or aggregate going to pass to my function as an argument? Those are the two main points I wanted to emphasize before concluding this part of the lecture. So keep in mind, whenever we want to transform or aggregate a pandas object, we're going to be using apply or aggregate. We will almost never do explicit iteration over a pandas object. And when we're defining the transformation or aggregation functions that we'll be using with apply or aggregate, we should be thinking about what those functions will be receiving as arguments. In the next video, we will mostly be talking about joining together data sets and combining multiple data sets.